So a few weeks ago, I stood in front of my heat pump and I told you that gas was cheaper. It was cheaper to run a gas boiler than it was to run a heat pump. Then things changed. This guy and this guy dropped a whole load of these on this guy. Then this guy launched a whole load of these and did this. And because of that, we're all paying massively more for our electricity and our gas. So today we're going to use real world tariffs, the things that you can actually go and sign up for today, and figure out, is this now cheaper to run because of the price of gas? Before we get into this, I want to set some ground rules, because otherwise these kind of videos can get very confusing very quickly. Now today we're not going to talk about my setup at all. We're not going to talk about solar and batteries. We're not going to talk about any clever ways to use smart tariffs to get you the best possible price. We're going to use fixed tariffs. Now the reason we're going to do that is if you were to switch tariffs today, pretty much the only options available to you right now are 12-month or sometimes longer fixed tariffs. And the reason for that is there is so much volatility in the market. The energy providers, they don't want to be exposed to that, so they're only offering fixed deals right at this moment in time. Now, we're also going to assume that our heat pump is completely average. It's going to have a coefficient of performance of 3. Now, I know when we do these comparisons, most people say you need a coefficient of at least 4. So we're going to artificially hamper the heat pump by saying it's a mediocre install and it's got a coefficient of 3 averaging throughout the whole year. I know that's not realistic, but that's the number we're going to use. And more importantly, we're going to compare full running costs, including the gas standing charge, which if you were to move to a heat pump, obviously you wouldn't pay any longer. And if the heat pump can still win after all of these, then we've moved into some very interesting territory. Now, before we start, let's get rid of one of the most common things that I hear. People say gas is around today 7p a kilowatt hour. Electricity is around 30p a kilowatt hour, so gas wins. End of discussion. But that's not really how heating systems work. If you put 1 kilowatt of energy into both a heat pump and a gas boiler, from the boiler, you're going to get about 0.9 kilowatts of heat from that 1 kilowatt that you put in. From a heat pump with a coefficient of performance of 3, you're going to get about 3 kilowatt hours of heat from that same 1 kilowatt of energy. So in this case, the heat pump is roughly 3 times more efficient than the gas boiler. Now let's take a look at some real numbers. So I went to the Octopus website this morning and I put in my postcode and said what kind of deals are available. And the two that we're going to focus on here are the Octopus 10-month fixed March 2026 V2 for anybody who wants the specifics. The numbers should be the same in every region. Your standing charge will vary by region. But if we look down here, we can see that gas is about 7.2 pence per kilowatt hour, with a daily standing charge of 33.38 pence. And that gives us a rough standing charge for the year of about £122 for gas. Now, we could just use that same electricity tariff, the fixed tariff, but the reality is anyone who's getting a heat pump, even if you don't have EVs or batteries or solar or any of those other things, you're probably going to go onto the Cosy tariff because it's going to be a little bit cheaper than the standard fixed rate tariff. But Cosy right now is also a fixed rate tariff. Now, depending on when you go, some days I've seen it as a 6-month fix, some days I've seen it as a 10-month fix. This particular day, it was a 12-month fix. And you can see Cosy has 3 different rates. It has its day rate, its Cosy rate, and its peak rate. Now, the bits you can see in purple there, those are the new rates, the changes that will come into effect on the 1st of April. So we're going to take those changes because if you were to fix today, those would be the prices that you would get in just a little over a week from now. So that means we have a Cosy rate. That is where we get 3 low-cost periods a day, totaling about 8 hours. That would be about 13.43 pence per kilowatt hour. We have our day rate, which is the vast majority of the day, at 34.54 pence per kilowatt hour. And then we have the peak rate, which is between 4 and 7 in the middle of the day. That's at 48.3 pence. God, that's painful. But those are the three different rates. And then we have a standing charge of 50.53 pence per kilowatt hour. Now, for the electricity side of these calculations, we're not going to remove the standing charge. We're not going to factor it in because you need that for everything else that you do in your house, not just your heat pump. Whereas if you were to get rid of your gas, you could actually save the money from that. Staying on gas isn't going to save you anything on your electricity standing charge because you still need electricity for other things in your house. Okay, now let's be realistic here, because if you just install the heat pump and again, you don't have any other technology in the house, you're going to look at your heat pump and say, what is the cheapest way I can run this? And I think a realistic split would be to say 60% of your usage would be on the cheap rate. So that's the 3 dips during the day that you get. That's where you would basically run your heat pump hard, you'd build up the thermal mass in the house, and you would then switch the heat pump off during the peak period. So you're not going to be able to do that all of the time, all year round. But I think 60% cheap, 10% peak, and then the remaining 30% throughout the rest of the day. That seems like a realistic pattern, and also kind of similar to how people would use a gas boiler where they'd kind of heat the home in bursts. Once we've done that, we can work out exactly what each of those individual rates are, or how much we would spend for each of those individual rates. And then we can work out an average price per kilowatt hour for the Cosy tariff. And that comes in at an average of 23.25 pence per kilowatt hour for and effectively across a whole day. And then, as I said before, we're going to assume that our heat pump has a coefficient of performance of 3. Again, not realistic. Most people's heat pumps run significantly above that. Mine runs at about 3.9 to 4, depending on the day and how cold it is. But we're going to say 3 just to keep the math simple. So if we take our effective rate and we divide it by 3, that means our effective price per kilowatt hour of heat generated by the heat pump is 7.75 pence per kilowatt hour. How much is it going to cost to run for the whole year? Well, I went back and looked at my house for the whole of 2025, and we used 9,981 kilowatt hours of heat to keep the house warm. So just under 10,000. We'll round it up to 10,000. So an average house using 10,000 kilowatt hours of heat. Now remember, that's not kilowatt hours of energy. That is how much heat we got out of our heat pump. So if we actually work on the principle that a modern gas boiler is going to be about 90% efficient, we would actually need 11,111 kilowatt hours of gas energy to be able to produce 10,000 kilowatt hours of heat energy. At 7.2 pence per kilowatt hour, that gives us a nice round bill for the year of £800. Then we add on our standing charge of 122, means our total price for running our boiler for the whole year and keeping the house nice and warm would be £922. Now, if we look at the heat pump, we take our 10,000 kilowatt hours of heat and we multiply that by our effective rate. Remember, we took the Cosy rate, we divided it by the efficiency of the heat pump. That gave us 7.75 pence per kilowatt hour. Multiply that by 10,000 kilowatt hours of heat that are required. That gives us a price of £775. You can see where this is going. So £922 for gas, £775 for the heat pump. That means the heat pump is £147 cheaper. Everybody is telling you to fix your prices, and this is why. So this simple chart here shows gas. The arrow you can see on the chart there is roughly at about 7.2 pence per kilowatt hour. So you can see there, when we factor everything in, you're paying just over £900 a year for gas to heat your home, and a little bit of gas that you might use for cooking. And obviously the dotted line across there, that is the Cosy rate that we just talked about. And again, I've put that in as a fix because I want to be able to show you the difference. Whereas if you were to fix your electricity price, obviously it's going to stay the same for the term of that contract. But the graph as it goes up there shows what happens if the gas price continues to rise. So you can see from the chart now, if the gas bill were to jump to 9p a kilowatt hour, your gas bill will go up to about £1,122 a year, including standing charge. That would make the heat pump £347 a year cheaper. At 10p, the heat pump will be saving you £458. Now, it's really important that if you haven't fixed your gas price right now, please go and take a look at the prices and make the call and fix your gas price. The reason I'm saying that is, yes, this might all be over in a couple of weeks, but it's going to take a significant amount of time to repair the damage to all of the infrastructure in the Gulf, to start getting the ships going back again through the Straits of Hormuz, and it's likely that gas prices are going to remain high for a large portion of this year. Now, a bit of a reality check, because this only works if you configure the system properly. You need to be on a smart tariff. If you were just on that fixed 30p a kilowatt hour tariff, you would be pretty much on par with the price of gas. And obviously, if gas were to go up, then there would be a difference between the two. But right now, that wouldn't save you any money. So by being on, at least on the Cosy tariff, and you start shifting your usage to stay away from the expensive periods of the day, your system is set up properly, maybe with a better coefficient of performance than 3, then you'll start to see the advantages. If you don't do that, all of the advantages of the heat pump disappear. So just to sort of reframe this, because I keep revisiting this topic because things change, but this really isn't about gas versus electricity anymore. It's about how your system is optimized. You know, even with a gas boiler, you can optimize your system. You can turn down your flow temperatures. You can fix your rates. You can do things to make sure that your bills are not just going up month on month. And with a heat pump, you can make optimizations. You can, avoid expensive periods of the day when you're, instead of running your heat pump at 6 o'clock in the evening, run it at 3 o'clock a little bit harder and then turn it off. You can make tariff optimizations. There are so many different levers and knobs and things that you can twirl with a heat pump to help bring your cost of running it down. So a month ago, I said gas was cheaper. And at the time, I was right. But today, that's no longer true. And because when the facts change, so does my opinion. That's it for today's video. I hope you found this interesting. As I say, things are in flux right now. These things change every single day. And until we get some sort of normality and stability back into the world, I think we're going to be fighting rising energy prices for the next probably 12 months. So if you take nothing else away from this video, if you are still on gas, please, please, please look at fixing your gas price. It'll probably save you money in the long run. With that, I'm going to sign off. If I'm lucky, I'll see you back here real soon for another video. Take care. Bye-bye.